So in frequency modulation, we are going to change the frequency of your carrier wave according to the displacement of the information signal. So how do they change the frequency here? If it's positive displacement of your information signal, then your frequency will be higher. If there's negative displacement, you make your frequency lower. So positive displacement, make the frequency higher. If it is a little bit positive, then the frequency will increase a little bit. If it's very positive, then the frequency will increase a lot. If it's a little bit negative, the frequency will decrease a little. If it's very negative, then the frequency will decrease even more. So in frequency modulation, what we will do is we only change the frequency, as you can see here, but we will not touch the amplitude. The amplitude will remain constant. So if you want to get the frequency of this wave, is actually the same as this. So the frequency that you send out, this is a frequency modulated wave, where we have the same frequency but just a small variation along the way, plus minus. But the frequency that you tune to will still be this, because in this wave, you see what is the problem with frequency modulation? If you pass it through a frequency analyzer, remember I was telling you what's a frequency analyzer? If you take this wave, you put it into a frequency analyzer, it will tell you what are the waves hidden within this wave, right now. So in AM, you have only how many waves? 3 only, right now. But in FM, what will happen is this, you will have the middle, which is FC. Then you have the sideband, which is FC plus FA, right? And FC minus FA. So now, this is in the amplitude modulation. In frequency modulation, inside this wave is hidden infinite number of waves. So you will also have multiple sidebands here and multiple sidebands here. It goes on and on. So what are these sidebands? So you will have FC plus 2FA, FC plus 3FA, FC plus 4FA, FC plus 5FA, and so on and so forth. On the other side, it will be FC minus 2FA, FC minus 3FA, FC minus 4FA, it goes on and on. But the good thing is, as you go away from the middle, the amplitude starts to drop right now. So when we set the bandwidth, we don't have to set the bandwidth until all this won't exist anymore, because it will be impossible, because it's infinite number of waves there. So, but you can, once the amplitude is small enough, then we don't have to worry anymore, because you will not affect us. So our bandwidth for FM is usually higher. One of the reasons is because of these multiple sidebands. We have to allow space for these multiple sidebands for their amplitude to become negligible. Then only we set the bandwidth. Understand or not? So you will notice later on, one of the reasons why FM has higher bandwidth is to allow for all these multiple sidebands. So if you see only 3 lines, I told you it is definitely AM1, because FM will have infinite number of waves. Understand or not? So what is the definition of FM? So the definition of FM will be the frequency of the carrier wave is made to vary in synchrony of the displacement of information signal. That means you will change the frequency according to the displacement of the information signal. The amplitude of the carrier wave does not vary, so you notice it's a constant amplitude. The change in frequency is a measure of the displacement of the information signal. That means how much frequency you will increase depends on how positive it is. How much it will decrease depends on how negative it is. Now this next sentence is optional. If you don't want to write, also can. For positive displacement, the frequency increases. Negative displacement, the frequency decreases. That one is optional. But the last one is important. The rate at which the carrier wave frequency is made to vary is equal to the frequency of the information signal. So what does it mean? How many times this wave changes from high frequency to low frequency to high frequency depends on actually this frequency. Because every time you change from peak to trough to peak, it will change from high frequency to low frequency to high frequency. This one change more times, this one will change more times. That's what they're trying to say. Okay?